Oh, okay, great. So today we will discuss about biogeochemical cycles. This is something I kept on referring in my previous videos. I just realize now. Um, so we'll talk about four main chemical or elements cycles. So the carbon, phosphorus, nitrogen, and something else. So what are these biogeochemical cycles? So biogeochemical cycles are defined as a process involved with cycling of a chemical element through its various biological, chemical, and geological forms in air, water, and soil. So although we are going to study more in detail about these elements particularly, but like in a very broader sense, I would just highlight that these elements are world population or our food system or whatever. Nature has just its own way of restoring everything, keeping a balance of everything. And that's not just from this mythological or like fancy language that I'm used speaking for, but nature does it very much scientifically, and we will dig more deeper. How does it that do that? So when we study about the elements, you'll understand how just the misbalance or imbalance of one chemical could impact on the entire system. So from the system, I mean the entire world. Similarly, just by the loss of one of the biodiversity species, everything is impacted. So you might have heard normally, like if we lose this especially our food, like our entire food chain, our entire biodiversity system, our ecosystem would be disturbed. Maybe that doesn't really make sense when we are not thinking about it in depth, but when you look at, for example, there is an especially which cleans the environment for us, and then the species itself is a source of food for the next species, which happens in the food chain as we studied in our high school. So if we humans consumed or like by our any of our activities, either we ate the entire species and like there's no more of even a single not a question, but a single animal of that species or animal or whatever, then it impacts the entire environment. I will recommend, as there are a couple of links inside this tutorial of some of the amazing Netflix series, which you would, I would really recommend. If you know Sir David Attenborough, his voice commentary in one of the recent series, Our Planet, and its second season, those kind of described all of these things in a very beautiful way, with beautiful videos in the background, and they explain how does it work. Coming back to the content of this course, so we'll begin with carbon cycle. So biogeochemists often examine the carbon cycle in two separate subcycles. So one is biotic and other is abiotic. And it's living and non-living cycle of the carbon. 1 second. From the abiotic carbon cycle, we mean that it consists of all the carbon cycles that involve non-living components. So carbon is, of course, one of the very important source like of our existence even, and like even yesterday I'm blushing because even yesterday I was talking to a friend about net zero carbon and all that, and then she was referring to like we human keep on like working with carbon all the time. We eat carbon, so like whatever food we eat, our food is coming from carbon. We exhale carbon all the time. What kind of carbon zero, net zero are we talking of? So carbon is like of course it's the carbon is not the bad guy here when we speak of net zero and all these fancy terms. Which so understanding of all these terms is really important because you're going to write an op-ed for a broader audience. You should You should be very clear. And like even like even myself, even if I like write these kind of terms, um, even if I have a 1% doubt of my understanding towards these terms, if I'm writing something for a broader audience, I would go and double check the concept, because these terms, such as even the biotic, for example, carbon cycle, we could be pretty wrong about the way we understand it and understand it. Okay, so how does carbon keep a balance? So, like we understood that it's one of the two ways: living ways and non-living ways. From a non-living way, it could be through rock weathering. The carbon its leakage subcycle. So, driven by the reaction of atmospheric CO2 and water, carbonic acid with the earth crust in the process of rock weathering or the erosion process is created, and that's how carbon is created naturally. So until now, we are talking about the like we say organic way of creation of carbon, and then from the bicarbonate it moves to ocean via rivers. Then this becomes part of the oceanic crust through deposition of calcium carbonate, and then that's how it's made. Ocean sequestration. So we understood how it's created, and then how nature keeps the balance of it. So atmospheric CO2 dissolves. So once we had this, uh, yeah. So then, like, how does ocean carbon sequestration, and then it would distribute more evenly throughout the ocean depth. So, sorry. Or atmospheric carbon dioxide dissolves in ocean as governed by the Henry's law, which states that describes the distribution of any gas with significant solubility between the gases and liquid phases in a closed system. So this is very like what we have understood. So when carbon dioxide meets with the hydrogen in ocean, essentially, as we know, a bigger part of our Earth is just water. Then it's broken into hydrogenic ions, and then finally it's into H2CO3. So the ocean acts as a buffer, acts to buffer changes in atmospheric CO2 concentration. So it has been working like as an atmospheric buffer to sequestrate the carbon of the ocean, and that's how, if they are being impacted, it disturbs the entire site, entire ecosystem in the ocean. So the next thing we are going to discuss is the thermohaline circulation, the seasonal downwelling of cold polar waters driven by temperature and salinity. As surface water gets colder, water with lower salinity freezes and becomes part of the polar ice structure. So this is the system of how wind is like, how different winds from, like we have heard, from coming from south, north, that those are created by the difference of temperature and salinity. And then cold and saline water sinks in zones of downwelling, which creates deep sea currents and carry dissolved carbon dioxide to the deep ocean. So again, when the warming increases, as we saw in the video also, that in a couple of years, even if 1 degree Celsius change. So when we say 1 degree Celsius, just a disclaimer here that it's not just it's not as equal to the 1 degree Celsius as we see, for example, rise in 1 degree, inside our living hall. We're talking about 1 degree increase in global average. So, and we're talking about all the countries, and like over speaking of all the temperature record since we started to record temperature. So that 1 degree rise as a global average, it is a lot. It is going to impact a lot of things. It's not simply 1 degree rise. It is so when it is one to reach in global average of 1 degree rise, it must have been like a couple of degrees increase in some of the places, and whereas in Ireland it's not as big, but even we could see the impact. And if you have lived longer in Ireland, you might clearly see the difference between summers in previous years and now. Okay, so the temperature, there is reason to suspect that the thermohaline cycle could slow down or stop completely, which creates our winds and which is like a natural another way of keeping a balance of things, because like it's driven by temperature, and if temperature continues to rise, so this temperature difference of hot and cold would end, and from the heat we know that heat is driven through the temperature difference to from one place to another. This is another video we'll watch. Let me know if you can hear the sound.
We as oceanographers
Can you hear the sound?
Yeah.
Yeah. Okay.
refer to something called thermohaline circulation, and that's the circulation that involves transfer of water from the surface and in the polar regions into the deep.
So in Antarctica, where the waters are super cold, -1, -2 degrees centigrade, when it's winter, the sea ice freezes.
The first thing you need to do is drill through the ice. If you can't get to the ocean, you can't do oceanography through ice. Shoveling? Okay, so this is the main reason we're working out here. These are ice platelets, or platelet ice. You know, some of these can be 50, even 70 millimeters in size, but really quite thin, and you know, almost fresh water. Well, it is fresh, and so we think it plays a role in the growth of the sea ice. So this ice basically grows in the water column, and then it's buoyant, so it floats to the surface, or not the surface, but the underside of the existing sea ice. Then it sort of becomes amalgamated into the sea ice.
Sea ice, when it freezes, expels salt. So you're adding salt to this super cold water. It becomes super dense and then dives down to depths of 4, 5, 6 kilometers.
Deep water is forming at both ends of the planet. Right now, I think that about half of the deep water that what we say ventilates the deep ocean is happening in the North Atlantic, and the other half is happening around Antarctica.
And they set up this rather marvelous global circulation pattern, the thermohaline flow. Haline, the Greek for salt.
The ocean carries something like half of the heat that gets to the polar regions. And that's part of the thermohaline circulation, because water is flowing at the surface toward the poles in a sense. It's cooled and sinks at the poles and then comes back up somewhere else.
Where I come from, Edinburgh is on a fairly similar latitude to kind of Moscow or St. Petersburg almost, which are places which get incredibly cold winters. Except I, you know, enjoy a relatively balmy Scottish winter at, you know, 5 degrees or so. To some extent, that is as a result of water that is pulled north through the North Atlantic by the sinking action of that North Atlantic deep water. There's been times in the past when that's shut down and caused a huge, very rapid freezing around Northern Europe.
We do see changes in the ocean circulation. We do see changes in the salinity of the ocean. So at the polar areas, the waters are becoming less saline, which implies that they're becoming less dense, which in turn, if we extend that back to our discussions on the thermohaline circulation, if the density of those surface waters is starting to decrease, then we may be altering the way the thermohaline circulation operates, which means that we're altering the distribution of heat around the planet. That is a big change if it happens.
Well, if it happens that the thermohaline circulation really shuts down, this is confusing the entire circulation, the wind system and the ocean systems globally. First, what happens is you just get a strong cooling in the high northern latitudes. But it doesn't mean that we get a cooling altogether over the globe. You just redistribute the heat. So eventually you will get a warming in the south that is even stronger than what you would have from the global warming.
I mean, we can never say that we understand things well enough to eliminate the possibility that, you know, there could be a sharp change in thermohaline circulation. But I think we have many other things that we should worry about more.
So that was about the like non-living side of the things, keeping a balance of carbon, and like on speaking of are like living things. So of course we know trees, the biotic carbon cycle consists of all carbon subcycles that involve living organisms and their processes. So that involves us too as well, photosynthesis and our respiration again. If anybody has any question, they can please raise your hand and I'll stop. The photosynthesis, so when we know that carbon dioxide from the atmosphere meets the water, plus then there is the sunlight, it creates glucose and oxygen from the plants, which of course this is the basic thing that we understand why plants matter, why are plants important, because not only they give us food, but then they create oxygen, which creates then balance of this carbon and oxygen equation, and that's how plants are good for the environment, and forests from being lots and lots of plants. The processes by which green plants and some other organisms synthesize carbohydrates from carbon dioxide and water using lights, that's called photosynthesis. So respiration, so the glucose that was made from plants, C6, H12, and O6, and then we also breathe the oxygen coming from the plants, and when it meets with the water, it creates, then what we exhale is carbon dioxide and water, and also that the energy is released in that process. So that is called respiration, and that now this carbon dioxide, which we can see, is coming from the natural processes of, we can say, as part of the biotic carbon cycle. So the growth of more photosynthetic organisms captures this 105 pgc per year net primary production. So this uptake is a result of photosynthesis. When these plants die or decompose, carbon dioxide is released by respiration. And that's why it's important to understand that just by continuing to but by planting more and more trees, it's not right away good for the plants. I'll just refer to one example of, for example, carbon offsetting. So in terms of carbon offsetting, what we do is that we just buy carbon credits, and we say, in return of this money, we will plant 100 trees and so on. So for the planting 100 trees, if other 100 trees have to be replaced or like planted new, so there are two things happening. So the old trees, if they have to be like cut down, they add a lot of new carbon dioxide to the atmosphere. And the new plant that we plant today is going to take 5 to 6 more years to come to the equal position of absorbing that much of carbon dioxide that the previous tree was absorbing. So about 15% of marine net primary production sinks to the deep sea, acting as a biotic pump that transfers carbon dioxide from the atmosphere into the deep sea waters. So we see here that ocean is really, really important for absorbing the carbons, and it has so many rich ecosystem within its inside, which helps us to keep a balance of carbon. So carbon dioxide enters the atmosphere through burning fossil. So these are like, now I'm coming to the more like, even like, so that was natural way of us breathing, respiration, and like even if 8 billion people are respiring and eating, that would have been okay. But all of our activities such as coal and naturally burning of natural gas, coal, and the amount of waste, solid waste that we 8 billion people produce, and then to meet our needs, we consume wood products, and then as a result of certain chemical reactions. For example, in manufacturing of cement, a lot of carbon dioxide is generated, and this carbon dioxide is removed from the atmosphere when it is absorbed by plants. But of course, the earth has its own capacity or own limitation of absorbing the carbon dioxide. It cannot absorb unlimited amount of it. Methane makes up just 16% of global greenhouse gases, and it's a shorter lived than carbon dioxide, but it is more dangerous than carbon dioxide. So there are GHG is the term for greenhouse gases, and then there are different gases inside it: carbon dioxide, methane, and so on. And so some are more long living. For example, carbon dioxide is long living but less impactful. But long living makes it, for example, the carbon dioxide, which went up in atmosphere in 1950s, it's still there. So the methane could die out before, and like it can like not die, because like we know the basic laws of mass and energy, that it could not just die itself, it can get converted to some other form, but carbon dioxide lives longer. The next is nitrogen cycle. I'll stop here if anybody has any questions. Okay. So nitrogen also, like, it has also atmospheric origin. It comes in form of N2. It's about 78% in our air, and mainly it's N2. So productivity of most ecosystems limited by availability of nitrogen, and nitrogen is one of the essential form in our fertilizers as well, which we keep to continue the enrichment of the soil, which we discussed during the our last tutorial as well. So the role of nitrogen in the plant, nitrogen is a major part of many of the plant's compounds, for example, amino acids, enzymes, and nucleic acids, and so on. So for the distribution, most nitrogen in terrestrial ecosystem is found in the soil pool, and 10 to 20 times less content in vegetation pool, and mostly found in the top layer of the soil. There are these are some of the forms how nitrogen is found, and so principal nitrogen cycling processes. So that's how the nitrogen is then, like, the earth keeps a natural balance of nitrogen. It's through fixation, mineralization, and we'll go those one by one. And so nitrogen fixing is one of the process, the conversion of atmospheric nitrogen to ammonia carried by nitrogen fixing bacteria on the roots of leguminous plant. The second process for the nitrogen cycle is nitrification, the conversion of, so from nitrogen we create, like, the earth created ammonia. From ammonia it creates nitrates carried out by another bacteria. Ammonification is the conversion of biological nitrogen to ammonia carried by another type of bacteria. Denitrification is, of course, opposite of nitrification, and it's the conversion of nitrates to nitrogen gas carried by and other bacteria. So it's important for the soil quality. So what happens is that when we continue to grow crops on the same land for again and again, then we take the balance of nitrogen from it, and we then to keep the earth soil rich. I'm sure, like, if anybody of you do farm gardening or farming, you understand this much better than me. Then we keep the balance of nitrogen, we keep the fertilizer in the soil to um, to have the same quality of the soil. Assimilation is a process in which plant uptake of soluble low molecular weight compounds, nitrates, and ammonium. When nitrate is assimilated plants and microorganisms, it is first reduced to ammonium prior to its incorporation as amino acids. So that takes step by step. What is fixation of ammonium? So the ammonium ion NH4 can be fixed by clay, colloids, and humus. Still available for plant uptake, partially protected from leaching. It occurs mostly in the subsoil rather than the topsoil. So what happens in agriculture versus environment? So agronomy, for example, is grassland and tillage production. Do we have someone in the group who could discuss more on what is tillage? Okay. So what happens is that for in terms of agriculture, there are different ways to, how to say, different ways to cut the crop, kind of. And so when you and like, or to do with respect to the season. So if you just continuously do it, the earth is not, the soil is not like, uh it's not an unnatural thing that whatever we do and it would be still be back. So whatever processes in terms of how many times, the number of years we do it, it impacts the quality of the environment and the soil, and then it creates the balance. So tillage and these are kind of techniques which help us to improve the quality of the soil. Next, we have phosphorus cycle. The soil phosphorus cycle is a dynamic system involving soil, plants, microorganisms, and animals. Soil contains between 100 and 300 total phosphorus in itself. Most phosphorus occur in surface horizon, just like nitrogen, due to absorption of added phosphorus, greater biological activity, and accumulation of organic matter. It is also one of the plant nutrient essential constituent of living organisms. We have inside us so many different kinds of elements. Phosphorus is not reduced in plants; it remains in highest or oxidized form. Transfer of energy through ADP and ATP. This is something which we learned when we were studying in high school about how is ATP is a complex organic chemical that participates in many processes, and it involves in the our energy structure as well, involved in active uptake and transport of ions, and this is synthesis of organic molecules. Seeds require phosphorus during germination, and then after germination is the process in which the seed opens up and then it grows into a plant. Phosphorus origins into the natural sources, and it plays a role in soil development. So major, and it is found in one of the major reserves in the earth. I am skipping some of these slides because this is the repetition of what I'm saying, and I'm trying to move towards Ireland's situation with respect to these cycles, biogeochemical cycles. The processes that governing soil phosphorus availability is like, again, it's divided into biotic and abiotic, which is living and non-living way of doing it. Absorption reaction involves the removal of phosphorus from solution by concentrating it in or dissolved phase. Loss of phosphorus from solution can result from either adsorption or precipitation. And then adsorption could also be defined as concentration of substance at an interface in case of phosphorus. This interface is the solid Digger interface. Phosphorus in Ireland grassland. So phosphorus cycle in grazed grasslands ecosystem. So as we already discussed, that the overdoing of anything is of course not good, and then if it's overgrazed, it impacts the quality of all the elements. Now we'll discuss agriculture versus environment. So sustainable forest usage is required. When we cannot do it naturally, we essentially do it through the artificial way.